So, my name is Jeff Mucci. I'm with RCR Wireless News. Today we have two speakers from JDSU who will be talking about optimizing small cells for coverage capacity and really looking at an end-to-end approach to coverage capacity. Our first speaker will be Jason Byrne. Jason, I'll turn it over to you now.
Great. Thanks very much, Jeff. Much appreciated. Again, my name is Jason Byrne. I'm in product marketing here at JDSU. We'll also have Kangru from business development speaking towards the latter part of the presentation. So like Jeff mentioned, we really want to take we're optimizing small cells for coverage and capacity. Let's get started with a quick, if we move on to the next slide here. Let's start on the top left-hand corner. I really wanted to get a quick review of some of the relevant metrics that pertain to small cells. You're probably familiar with the latest Cisco mobile data forecast, 2012. In the report, it actually highlighted that by 2016, the data growth of mobile networks will grow to be 18 times last year's capacity. I don't know about you, but that's a staggering number, and certainly enough to keep NAMs and operators up at night. So moving to the graphic on the top right, we really address the question, where exactly is all this traffic being used? Well, as you can see, according to some market reports, 80% of all data traffic is now accessed indoors. And by indoors, I mean in the home or in buildings such as shopping malls, offices, that sort of thing. Now, if we move to the next metric on the bottom left corner, this is where we answer, well, what is and what will make up this big data? And really the staggering number is that by 2015, 70% of this mobile data will be consumed by video. I know that we've just passed the 50% mark this year. So 70% over the next couple of years is certainly mind-blowing. Things like Netflix, Hulu, etc. really dominate that picture. And then the last metric I want to drive home really is that some reports really show that 90% of all data traffic is handled by less than 10% of the cell sites. So in summary, these metrics really, I wanted to highlight the trends in mobile usage and really the need for the solutions like small cells and hetnets. Now if we move on to the next slide, if we see here, I wanted to show a quick summary of the benefits with small cells and hetnets. Obviously hetnets simply indicate the use of multiple types of access nodes in a wireless network. Right? So for example, existing macro cells overlaid with things like with small cells such as metro, micro, pico, femto. And those small cells are typically used in places like in-building, offices, shopping malls, or dense urban public places, and obviously at home. So now let's get into really, what do small cells actually bring to the table for the end users? Well, first off, from a high level, it moves the base station closer to the user equipment. And what this does is generate a much higher quality air interface. And subsequently, obviously, that results in faster, more reliable data connections, higher data throughput, which obviously results in a better end-user quality of experience. In summary, I guess, really placing coverage and capacity where it's actually needed, and that's what small cells are. And just to highlight the recent interest in this, AT&T unveiled its Velocity IP program at the analyst conference last week, where $8 billion, the wireless part of that program, of this 3-year program, involves deploying about 10,000 macro sites, 1,000 distributed antenna systems, but it also includes 40,000 multi-mode small cells, whether it's 3G, LTE, Wi-Fi, etc. Okay. Now let's move on to the next slide if we can. Now let's dive into some of the major factors affecting a small cell roll deployment. In a recent Informa report which polled vendors and operators alike, the largest concern was found to be backhaul at almost 29%. And really with backhaul, careful planning and performance management is required, really to avoid creating bottlenecks where capacity is restricted. The next most important factor really was making sure small cells coexist with the existing macro cell infrastructure. We'll see, with small cells, there's more handovers requiring, really an efficient and higher capacity to handle the resulting higher signaling traffic. We're already in a storm of signaling traffic. Well, with small cells, that's only going to get bigger. There's also more neighbor management, right? With small cells, with neighbor lists across clusters of small cells, and also with our larger cousins, I guess, in the macro network. Now let's cover the next most important factor, which is the self-optimizing or self-organizing networks. SON obviously enables coordination between all cells, harmonizes the parameters, maximizing the performance of the entire network. I guess, in other words, the network continually monitors its own performance and adapts itself automatically to achieve optimal performance while automatically coming into service. And that's a big thing. The problem arises when multiple vendors are chosen as part of that operator's network, right? Each with their own flavor of SON. And then the question becomes, how will they self-optimize across different solutions from different vendors? And that's something we'll touch on later on. Another important factor, I guess, is that of vendor interoperability. So, in other words, with regards to vendor interoperability, with such close interaction required between different layers of a hetnet, it is important that open standard interfaces are implemented. I mean, that's key for interoperability. These allow really different vendors, the vendors' products, to be used in different parts of the network. So that the best products or best of breed really can be selected. And the last thing I want to touch on really is the interference management. As the number of cells increase in the network, there are more cell borders, which leads to greater potential for interference. And as a response, small cells are automatically, they adjust their transmit power and scheduling of resources really to avoid that intercell interference. I think that's all I wanted to cover on this slide, just to give you a background on what are the factors affecting small cells deployment. As with any new technology, operators are wondering if they can really cherry pick. That's the promised land. Can they cherry pick the best of breed vendors across macro and small cells and make sure they work? And well, there really are two very different divergent stances on the integration of small cells into networks. There's one school of thought is that hetnets are best single sourced in order to ensure that tight coupling or tight coordination between small cells and their macro cells. With single source, you realize the full potential of SON. Right? You've got a single vendor with a single SON solution. There really is no need for coordination across different solutions. But the other school of thought, and this is what the promise is from small cells, is it's really a multi-vendor opportunity. It's 100% multi-vendor opportunity. But the problem with this is that not every vendor, or every vendor has their own flavor of SON. Okay? So how do you coordinate across multiple SON solutions? Just look at AT&T's decision to work with, I think it was Intercell, on its multi-vendor SON solution. Okay. Ultimately, only time, I guess, will tell which school of thought will win, but my hunch is, perhaps as with anything in mobility, a mix of both will probably come to fruition. Now let's move on to the next slide, where we really cover, so while coverage and capacity are the main drivers for small cells, we're all well familiar with that, those two drivers. Many vendors are actually adding intelligence to the device, right? And this is the key, right? It's got storage, it's got memory, it's got a CPU on there. Why not add some more intelligence, some more secret sauce, one by the vendors to differentiate themselves? But there's many benefits that are enabled both for the user and the operator. But introducing sort of non-standard products or non-standard features, that needs to be managed as part of that evaluation process. The first thing an operator really needs to deem is whether the features are actually relevant or needed or desired, I guess, for the operator's traffic profile. The next is how the performance characteristics can actually be evaluated. And of course, the major question is, what's the impact? If I introduce these new features that are non-standard, what is the impact of that into the rest of my network? Clearly things never go smoothly. And really a facet of this is when multiple vendors are selected, how do you make sure those multiple vendors work under a realistic load? And I really can't help to emphasize this as much as is that, wraparound testing really is not sufficient to measure the impact on the network. as we highlight the need to perform end-to-end testing and really measuring the impact as it cascades through the network. And this is why want to make sure we emphasize wraparound testing solutions have their play in the space, but they really do not measure the impact on the full network as you introduce these new features. So now let's look at some more, what features and that are detailed in some non-standard optimization techniques. What's coming to fruition? If we move on to the next slide, remember we already discussed improving the quality of experience by moving that base station actually closer to the user. But what's improving it even further is that by adding this intelligence, you reap the benefits really in two ways. The first is you really reduce the amount of backhaul traffic. Okay, if there's a method to reduce that peak traffic load, obviously that's where it's most impactful. And the second then is improving the user experience. Obviously this is an end user benefit. On top of improvement that you typically get from small cells anyway. So what if you're able to cache the content? Right? So now you can cache it locally within the cell. This implies when the user actually requests the content, it's played from the cache. So thus the user benefits from much faster response times, improves the user's perception and quality of experience. And then another feature being added to small cells is that of transrating, right? This video compression, where the codec is transrated right at the small cell, and thus reducing that backhaul bandwidth needed. And then with the combination of caching, many different video formats are actually stored on the small cell, again, so that when future requests come along, they're able to pull from the format that the UE supports without going through the backhaul. And then the last feature I want to highlight here is that of managed offload. And this is where the internet traffic, things like video is actually routed away from the core and sent through a different path, such as the homeowner's internet connections. Okay, let's dive into this a little more detail if we can. Let's dive into caching. Really research has shown that many situations actually arise where many users actually access the same content in the same geographic region. So things like sports games, videos that have just gone viral, things like that where the content is actually accessed by people in a similar geographic region and a similar time frame. So if we're actually able to predict the content that the user will try and pull from the network, that's really the concept of predictive caching. And you can see there's two concepts. There's predictive and proactive. And Intel's got a good white paper I'd encourage you guys to go look at also. But you can see here, the predictive caching where the carrier actually predicts the content and downloads it off-peak, right, which evens out the traffic profile. So I guess when the user pulls the content, whenever there's a hit, it actually comes from the cache, thus saving the backhaul. The other method on the right-hand side is this proactive caching. And that's very similar to what we have today, where I will pull content from the cloud or the server and watch it for the first time. But all subsequent plays for that content, whether it's me or someone else that's in that small cell, will be pulled from the cache. Okay? So those are the two types of caching mechanisms that we mentioned here. Let's move on to the next slide if we can, in the interest of time. So as you can imagine, internet offload. I'm sure you've come across this in many different forms, but internet offload is fundamentally really a response to growth in mobile traffic. The mobile industry has a long history in embracing technologies and approaches that could be categorized as internet offload. As seen on this slide, 3GPP has done a lot of work over the years, starting back in release 6, all the way over to release 10 with specs such as the LIPA and SIP2, which is more on the core side. Well, let's get into the details a little. Internet offload, like I mentioned, it comes in many forms. Let's talk about Wi-Fi offload on the bottom left-hand side. The big question right now is how will mobile operators play that Wi-Fi card? Should they continue to allow the user-driven model prevail? I know when I come home, it automatically roams onto the Wi-Fi, and that all future data traffic then while I'm at home goes through my Wi-Fi signal. Or should the operators actually take an active role in managing that offload solution, where the operator has more control on how and when and what traffic is offloaded. So, obviously operators are looking to tighten that integration between cellular and Wi-Fi. As shown here on this slide, the first is that of hard offload, which I talked about, which is the user-driven model. The second phase, which T-Mobile and Orange are already implementing, is more around, the offload is actually based on SIM-based authentication. Okay, and then the end game, or the third phase, we think, is where there will be tighter integration with the Wi-Fi access and the core, offering seamless session mobility. Okay. Now, if we move on to the middle part, which is the femto offload with femtocells, there's two major differences between Wi-Fi and femto, and that femtos are deployed in the licensed spectrum, okay, and that they are fully integrated with the carrier's network. It's the core network integration that makes the real difference. It really means the femtocells are transparent to the operator's networks, okay, and that's a good segue into offloading at the core, which we touch on the right-hand side. Let's start off with the ALIPA initiative. ALIPA is really part of the femtocell architecture. I broke it apart here, but you can see it's designed for use cases where the user really wants access only to local services, not the internet. Okay, I just want to be clear. Versus SIP2, on the other hand, is directly related to the core network, where the intent is to distribute the packet gateways so the traffic doesn't bottleneck on a couple of core gateways in the network. So there's many different formats that, I think I've spent enough time on this topic, but suffice to say, there's a plethora of offload mechanisms. And as with anything, I think a mix of all of the above will become common practice. Okay, let's move on to the next slide. Here I do want to touch a little more about Wi-Fi integration with small cells themselves. We can't go through talk about small cells without covering the actual impact of Wi-Fi on the carrier. And with Wi-Fi brings about, many benefits, right? There's the user side and the operator side. On the user side, I think we might have touched on this, is there's faster data connections, better quality of experience. And also, with Wi-Fi, you get better coverage, extended coverage within the building. As the walls between Wi-Fi and cellular start to break down, users are really demanding that seamless, secure access across mobile and Wi-Fi. The other face of this is really the benefits for the operator, and obviously this is the driver for this call. Is the first is the smart offload. This traffic shaping or fine-grained, intelligent traffic management that can be implemented with offload. The second is spectrum reuse, again, which has a potential capacity increase, which we discussed previously. Also is increased control of that user experience. As the operators take more control of that offload, they will get more control of the user experience. Again, trying to reduce that churn and get a better quality of experience. With various grades of service, obviously with different grades, you get different methods of increasing revenue. And I think the last thing we want to touch on here, really to highlight, is that with a highly regulated and standards-based mobile network, integrating Wi-Fi into the solution, whether it's as part of integrated into a single box or two separate boxes, it has many issues and challenges. And 3GPP has really stepped up to define, a standards-based approach to both networks, and we list some of them here. I think that's all I wanted to say on this slide, and with that, I think I'll pass back to Jeff, who might have some poll questions for you.
Thank you, Jason. What I'd like to do now is I'm going to launch a poll and to engage the audience and get a better feel for what the audience thinks is a realistic time frame for a UMTS or an LP small cell deployment. And we'd love for the audience to cast your vote. And we'll leave this open for 30 or so seconds, and then we'll close it and continue on with the presentation, Jason.
Okay.
Couple, again, housekeeping items. Please submit your questions during the webinar. We will have 15 minutes at the end for Q&A, but from past experiences, it does help to get questions from the audience during the course of the webinar, and the panelists will integrate responses to the extent it makes sense during the presentation. Okay, we've got about 60% of the attendees voting, and I won't share the results with you yet. Now, Jason, did you want to hold these results until the Q&A, or do you want to go ahead and show them?
No, we can hold them for the Q&A. It's probably best.
Okay, that sounds good. Okay, I'm going to leave it open for about another 10, 15 seconds. We've got about 70% of the folks casting their vote. Okay, last chance, 5 seconds, and I'm going to close the poll. Got a few stragglers coming in, Jason. Okay, I'm going to close the poll now, and we'll turn things back over to you, Jason.
Okay, let's hand over to Per Kangru. Per, over to you.
Thank you very much, Jason. So we heard Jason discuss and talk about the all of the good reasons why we would like to engage in femtocell or metrocell or any form of small cell evaluations and deployments. And the question then is, how can you basically get to the root of what is the right capability? How can you deploy it? How do you tune it? How do you roll it out? How do you manage it? And how do you really turn it into a both a strong profit generator for your organization, but then as well, how do you do that in a very effective manner? And what I'm going to share with you here is a couple of things related to how JDSU look at this segment and how we think about it. And fundamentally, we are starting from all of the aspects of what an operator would need to look at, or from a vendor perspective, what a vendor would need to do in order to effectively develop, market, sell, and support these type of solutions operators. So obviously, depending on where you start off from, you may start from basically a technology trial to evaluate, is this technology at all something that you're interested in? We've seen many operators already obviously deploy small cells. We've seen Small Cell Forum now has been up and running for a number of years, promoting the technology, showing that the technology is working. So some operators are way past that step, and obviously already selected vendors and it's in the rollout phase. But other operators, they really want to understand, does this technology bear the right concepts, the right type of capabilities for them? Is it right to go for a Wi-Fi offload technology? Is it right to go for an LTE small cell deployment, or is it something else that should be looked at and considered? So starting from that area, being able to go into the intimate details of everything, being able to stimulate, so actively test, actively stress the technology, actively run through scenarios, what happens in certain hotspot scenarios, what happens when you want to extend coverage, how do you make sure that you don't get too much interference, etc. This is all belonging in the first bucket of this, so the technology trials and the vendor selection area. And this is an extremely important area to get right. Many operators do not effectively utilize the power they have in this area to work with the vendors, to push the vendors, and actually find out what is the best solution for them. So this is an area where we are actively helping and supporting operators to be successful. Rolling over, as we heard Jason speak about, integrating small cells into your existing macro environment requires IoT, especially if you go to a small cell vendor which is not the same as your macro environment. So being able to have the right IoT and interoperability capabilities is absolutely crucial. So going through that in a structured manner builds a lot of understanding in the organization, which means that the latter phases of your deployment, your rollout, your troubleshooting, and your management of the network becomes extremely smooth. So going through all of these steps in the beginning lets the rest of the organization accelerate through the rest of the phases and really hit the ground running. So with that said, service creation. So obviously the question is, if you deploy small cells, why do you do it? What's the reason for you to do this? To drive top line to drive incremental usage, offload traffic, etc. How do you create the right offerings? How do you test them out? How do you validate that actually work? Not only from a lab perspective or from a engineering perspective, but out with your real users in a real environment. And this is as well where you start seeing going out, taking your friendly user trials, taking your close user groups, and validating. Does this technology work? Do the user understand how to actively use it? Even if a certain technology is beautiful and perfect from a technology standpoint, the question is, will the users adopt it? Will they embrace it? Will it be easy enough for them to use? Will it be seamless? If so, what will be the reaction of the users? And will you be able to meet your targets? So across this complete phase, JDSU have a breadth of tools and a breadth of capabilities, which really makes a lot of sense. So going into the next slide, please. So Jason, yes. So on the next slide, I'm really talking about instead of the rollout phase. So once you've iron out all of the kinks in the technologies, you have your vendors, you have your equipment, you have all of your equipment ready to go. The question is, how do you, in the most effective manner, bring that equipment, bring out those small cells to the environment? If it is home e-node-based, you need certain set of tools. If this is instead metro cells, which needs to have a dedicated fiber backhaul, you need a specific site clearance, you need to make sure that things are up and running, not interfering with your macro networks. So remember that small cells might be used to offload traffic from your most loaded network. Remember what Jason said earlier, 90% of the traffic originates from 10% of the cells. Given that, a wrongly placed small cell creating interference in those scenarios is going to cause a ton of extra problems for already very hard areas to manage. Therefore, it is absolutely critical that we manage the rollout phase, the integration to the macro network in an extremely good way. Because if something goes wrong here, you are in a world of pain. It's obviously not the same issues if you're deploying small cells to extend coverage, because then you're normally deploying them in an area where you have much less other traffic and much less other cells, and you're actually putting it there to extend coverage. So obviously, depending on what you're rolling out and for what reasons, this may or may not be critical for you. Jason, let's go to the next slide as well. So once you now have your network tuned, you have your network deployed, you have your services created, you rolled out your first commercial systems, you have your first set of users up and running in the network. How do you take care of them? How do you manage that you meet your targets in means of incremental subscribers, incremental capacity, incremental revenue, obviously, from that? This is where the JDSU tools for what we call converged assurance comes into play. This is where we give the operations teams the right tools to be able to go in, characterize all of the traffic, all of the users, all of the services, and very accurately being able to go in and both from an operational point of view support the ongoing customer care and customer management, but as well support the network operations, network optimization teams to make sure that the continuous tuning and optimization of the network goes very smoothly. So this is a sustained phase, obviously. This is where things continue for not only a couple of months where you roll out the network or the couple of months you prepare the network, but this is where you run your network for many years. And this is obviously where you need the right set of tools with the right set of practices and the right set of understanding of how do you solve the most crucial problems in your networks and deliver the right business metrics. So next slide, Jason, please. So let's look at some example of what this means and how we really connect these different phases together. So basically, from a business perspective, there is a dashboard which can show the data services. These data services can basically indicate that there is a deterioration of certain services. The question then is, for what reasons? As Jason spoke about, there is all of the different social media, there is the different applications and games that go viral, and in the industry, we can quite easily follow this, and we can really listen to the news and see the popularity of certain things going up. We can obviously study the network statistics and being able to understand these things from the network traffic. But we basically see that things go viral and specific applications really drive home. So the question then is, what happens to the network when this application goes viral? Why does certain KPIs go down, and how can you manage that? That is where JDSU take a closed-loop approach, and how we allow an operator to take this understanding about what's happening in the real-life network, turn that back into a simulation environment, and really load up in a lab environment, really load up network segments with small cells, macro cells, etc., and create these same scenarios and understand, why is my network infrastructure right now down on my knees? Is it because of the signaling storm? Is it actually because of the user plane? Is it because of something else? Is it some misconfiguration? Is it, what is triggering the unfortunate behaviors? And this is really where the value of what JDSU can offer comes into play. We provide a complete process of how you go from the top line down to being able to recreate, understand what's happening, take the right actions, put them into place, and being able to validate that, and that you didn't get any unwanted side effects from these changes before you very quickly can roll out these changes to the live network. And we're talking about things that previously have taken days and weeks and potentially months to be able to do a root cause analysis and wraparound on. We are now able to bring down to hours and days. So next slide, Jason. So practically what we're doing here and what we bring to the table is an ability to go from specific monitor data, being it trends, being it baselines, being it reports, etc., and move from just seeing these from a reporting or from a characteristics point of view, even if you can do troubleshooting and so on that data. What we bring to the table is the ability to turn these models and reports into real statistical models of user behaviors, and these are traffic models which we can take into a traffic generator and a application generator, where we can go in and very actively run this set of traffic over real RON environment, being it small cells, being macro cells, being it LTE, being it HSPA, etc., and being able to really push and see how this traffic and these behaviors cause the specific network segment or clusters of cells to either perform, and being able to, for example, evaluate what happens if we insert a small cell. Can that effectively offload majority of the traffic and significantly increase the capacity of my cluster, and being able to validate that in a real-world scenario rather than only from a planning software point of view. And it could as well be a matter of understanding what-if scenarios. So before you are launching a new application or a new handset, you're able to go and take your current traffic model, your current baseline of your real-world network, and you can say, what happens if I insert my new handset from a significant handset vendor, and that will have a significant uptake of hundreds of thousands or millions of people in the first few days and so on. Will that cause my network to actually go down? Will it cause my network to have significant issues? And you can do a lot of those what-if type of scenarios with this type of capability. So Jason, please So similarly, when we look at deploying the small cells, as we previously noted, small cells can be everything from Wi-Fi to home femto. It could be metro cells. It could be other scenarios. But ultimately, depending on your deployment, if it is a matter of adding capacity, being able to be very diligent about understanding that you don't have and you don't create a significant extra interference in your area. You need the right tools to be able to do the interference analysis, and as well being able to validate that this small cell, which you in most cases need to deploy in extremely large numbers compared to your current macro network. The question is, how can you very effectively and extremely cost-effectively roll out these very high numbers of small cells, but still ensure that you have the right and diligent installation, right and diligent commissioning and setup of these. Obviously, a lot of functions will be automated through some concepts, etc. But other things, you still need to do the what I would call the old hard way, which means that you need to validate that if using an optical backhaul and fiber to the antenna concept, you obviously need to make sure that that optical fiber is installed correctly. You're having the right characteristics of that fiber. You're able to maybe shortcut some of the traditional antenna testing, as you are may not have the same amount of antenna cabling. But on the other hand, you need to validate that the interference is not causing significant issues for your macro overlay. So similarly, you need to do this type of analysis not only on one of these cells, but as you start looking at the acceptance of a small cell deployment, you need to do your cluster acceptance. You need to look at how how the complete cluster of cells function together. Because remember, it's not only a small cell you deploy, you're extending a network so that you are getting an overall much better capacity and much better behavior. Therefore, you actually need to go through and do your acceptance of the whole cluster of both macro and small cells together, and that they behave in the correct way together. So regardless whether you're the operator looking for how you get the right delivery of your network from your vendor, or if you're the vendor selling and delivering these solutions, you really have to consider these things and how you, in a very cost-effective way, ensure this. And once again, JDSU has the right tools to be able to manage all of these tests, all of the processes, and as well how we structurally take all of the intelligence you gather from this and bring that up into the operational teams and give them access to this data and information. So Jason, let's go to the next slide, please. So as we mentioned before, when we speak about the concept of field to lab, so field to lab really means how do you effectively go from a lab where you can perform IoT testing, you can perform characteristics testing, you've done your vendor evaluation, you've done your vendor benchmarking, you've done your service generation, your service testing. How do you then take that information all the way through your friendly user trials, all the way through the optimization phase and into your operational phase? And then how do you turn that back from the operational phase into a improved and a further developed lab practice? And this is where JDSU is very actively developing a best practice for operators, for equipment vendors, in how to perform this cycle. We worked with a number of large-scale operators in building this concept. We have a portfolio that allows us to really bring all of these things together, all the way from the capacity and load side to the monitoring side in the live network, from the optimization in a live network scenario to obviously the functional verification inside a lab. And this is really crucial, because if you only perform simulated testing, if you only perform functional testing, if you're only performing monitoring from a live network, or if you're only going to a live network deployment without the lab phase, in many cases you are really up for a very bumpy ride. You are up to see a lot of surprises, and all of those things are generally not necessary to go through the roller coaster ride up and down in such an environment, but a carefully executed and planned environment where the JDSU tools and learnings bring things in order is really valuable. So let's go to the next slide, please. I've spoken a number of times around the what JDSU brings to the table, and what we bring to the table is tools and processes and capabilities in really all areas. And if we would have put all of the tools into this picture, this would obviously have been a picture extremely hard to see and understand. So therefore, we're more focused on the high level objectives. So we're talking about on the drive test side, where you basically can perform functional validation. You can perform RF validation. You can perform the type of RF testing in combination with functional validation. You can perform some limited amount of cell capacity testing with a number of UEs, etc. All the way through to the dedicated cable and antenna testers with base station testing, with our ENO-B RF test, over to the higher level signaling analysis, to being able to go into the details of end-to-end signaling, being it in the EPC or in the IMS domain, or going into the RON domain, being it in a UTRON or being it in a EUTRON, being able to look at any and all of the signaling across the network. So remember, when Jason earlier spoke about that, it's absolutely crucial to validate the right capability that you're looking to deploy, regardless of whether that is fully standardized from a 3D perspective, or whether you're working with a vendor that has a certain non-standard capability. Once you start looking into the details, both from an end-to-end testing point of view, but as well starting looking at the monitoring, you really need the right tools which can give you the right visibility in all of the interfaces and all of the capability of the network that you're validating. And that means that having the real end-to-end view is absolutely crucial. And real end-to-end view means that you have to be able to look into secured and ciphered communication. So much of the traffic, if you're, for example, using Wi-Fi offload, is likely to be ciphered and secured. That means that one has to be able to go in and pick up the right cipher keys, being able to use and deploy them at the right places. If you have those type of needs, please come and speak to JDSU, and we will jointly see that you get the right solution on that. Similarly, when you need to have visibility on a live network, when you start to have your actual deployment, JDSU have some revolutionary solutions. It means our packet portal solution. There is a lot of information on packet portal with on the JDSU.com website. So please go and look for that. Similarly, to packet portal, we have a solution called Packet Insight, which really gives a unique and valuable insights to very high data flows, and being able to go in and do a deep dive on that type of traffic. Both of those two solutions feature complete openness in where the data is sent, being it JDSU applications or being it open source applications. So that means that the data you're able to capture, the data you're able to analyze, you can utilize in any and all circumstances that you want it. So in addition to that, being able to run significant load, being able to take your ROM segments, being it of a couple of small cells, being it a couple of macro cells, building up a cluster, serving a certain area, being able to load that up with thousands of users, generating extremely high data rates and being able to stress significant signaling loads, etc. That is a very crucial test, and it's extremely important that when you select the right vendors and validate the right vendors, you're able to perform that type of testing, not only from a live network scenario when things go wrong, but being able to validate it in a lab network beforehand, being able to build up the practices to know when and how your network will perform. That's our JDSU capacity test solution. So with that said, you can go to the next step, Jason, thanks. So we really provide anywhere in the network, completely media independent, whether it's the copper part, it's the fiber part, the wireless part. We provide all layers from the physical layer all the way up to the application, either from a monitoring perspective or from a simulation perspective. So JDSU, if you're deploying small cells, if you're having a macro network, we have the solution that gives you all of the aspects from start to finish here. So with that said, I would like to see if we have any Q&A. So I believe we have the next slide here. Thanks.
Thank you, Per. This is Jeff Mucci again with RCR Wireless News. I appreciate you guys staying right on time. We do have the questions section open on the webinar, so please submit your questions. At this point, I'm going to share the results of our poll that we took midway through the presentation and really use that as a kickoff to get some responses from Jason and Per in regards to what time frames would be realistic for UMTS or a LTE small cell deployment. The results kind of speak for themselves here in terms of what the audience believes the time frame should be. Jason and Per, I'd love your feedback.
Sure, this is Jason here. So certainly, you know, I think the initial indications are from the market is that, you know, 3G small cells are going to be the mainstay for the next year or so. So I think that's probably what's driving the 6 months to a year. And then obviously 4G and LTE Advanced taking over as time goes by. So I think that sort of reaffirms that.
Per, any comments from your side? Any surprises there in those results?
No, this shows very well the distribution of different operators and different strategies. We're obviously seeing that there is a lot of activity now, which is I mean, in line with all of the traffic growth we're seeing on the networks, and I think everyone is looking for their right strategy for being able to address and take care of this.
Okay. Well, one of the questions I'd like to ask is, earlier you referenced a slide that had 3GPP and some other industry standardization groups. You know, where are we at in terms of status of standardization in the small cell industry? Does 3GPP cover all aspects, or who are some of the other influencers?
This is Jason here. I think I can take this one, Jeff. So certainly, you know, there's been internet offload's been around for a long time, long before probably 3GPP tried to jump in. So there's been many different vendor-specific, you know, solutions to some of the problems. Then some of the standards bodies got on, not just 3GPP. I just highlighted those here as the sort of the furthest along. But there's certainly a plethora of other standards bodies, the IETFs, you know, get involved. There's a bunch of folks that are still trying to further the some of that intelligence in the small cell. But what we highlighted here was just that 3GPP.
Yeah, one of the absolutely. Let me just add to Jason there that the 3GPP organization is obviously working working heavily to make sure that small cells are standardized, can blend in well with the rest of the network. And for LTE, it was very good that the home mean or D concept was actually introduced in 3GPP Release 8, which means that all of the LTE terminals, which is actually deployed out there, can function on top of small cells, which has been a slight issue with some of the small cell deployments for UMTS. So there's a lot of good work in standardization, and there's a lot of good work in other forums driving these capabilities.
Okay. Well, one of the questions we have from the audience asks for clarification on SIM authorization, and I believe that ties into some of the Wi-Fi Alliance Hotspot 2.0 initiatives. But I'd love to get your feedback on clarifying your comment on SIM authentication, and maybe that's a good provide some context on standardization.
Yeah, maybe I'll take the first part of this. Certainly, Jeff, there's, I mentioned about operators trying to take greater control of this offload and trying to manage that offload, right, where they can dictate what gets offloaded where and when. And I guess this is the SIM-based authentication, and I think I mentioned it was T-Mobile and Orange are trying to implement this, and it's really, really taking control of that. It's this moving from a dumb offload to a managed offload, and around the SIM-based authentication, making sure one that the folks that are on that small cell are actually authenticated and can use that small cell, and then two, what they can actually offload. I think the next step, obviously, is to get greater seamless tie-in between Wi-Fi and the cellular network. I don't know, Per, if you have any comments on that?
I believe that this is an area where there's a lot of implementation details which will really lead to whether this is effectively working in all of the areas. So many of the authentication systems that the vendors have are in many cases legacy, so they are essentially quite old, and it means really that even if the potential standard would support certain things, the question is whether the specific implementation that each operator sits with, both whether it can support it, and secondly whether it can support the extra scale, which it means if you start running a SIM authentication for Wi-Fi access, because one should remember that in many cases the full authentication and user management procedure over the macro network is often used on a very call it statistical nature, which means that as a user connects, all of the security and authentication procedures is actually only going to get executed on a, say, 10% of the time for each user. And it means that once the and that's obviously to make sure that the scale of the authentication infrastructure works well. So when moving over to a Wi-Fi based authentication, you might see a very significant load increase on your authentication system, which you have previously not seen. And even if it potentially could functionally work, the question is whether it's actually going to manage the load and the scale that you're now introduced to it. And what might be a viable setting to only do the full authentication, say 10% of the attempts on a normal macro network with a Wi-Fi offload, that may not be a viable and an acceptable situation. So it's once again, the devil is in the detail, and the question is, in a real live environment which operators sit with, what can be done in that, and how can you evolve from where you are to where you want to go?
Okay, I want to circle back to one of the, I think your next last slide when you're talking about the JDSU capabilities. We had a question in from one of the attendees asking what types of hardware is used for the KPI and ENO-B RF testing.
So I can take a stab at that question. So basically, this one is to be able to do the RF testing at the eNode B, we're speaking about the JDSU RF testing and an eNode B tester, which is a handheld analyzer for the field technician, which you can use out at the site. It's battery operated, it's handheld, and can function very well in that environment, automatically perform the testing, etc. Depending on what type of KPIs you're looking at, you can either get the KPIs out of this solution, or we can start looking at measuring KPIs from either an active test, so actually setting up a call, measuring the response times, measuring the setup times, etc. We can as well, from a core network and from a monitoring side, measure KPIs based upon probes sitting in the network. Those can be micro probes using our packet portal technology, and being able to provide you unique access into the small cells, or it could be more traditional probes sitting in the network, such as our Packet Insight solution, providing KPIs for very large segments of the network. Thank you.
Okay. We've got time for a couple quick questions. One question, what are some of the, in your opinion, what are some of the outstanding points to resolve for small cell deployments to become mainstream?
So let me take a stab at that as well, and Jason, you can add your comments as well. And fundamentally, what needs to be looked at before small cells can be completely mainstream is a couple of factors. First of it is a realization at the operator that this is going to be their strategy that they're going to execute to manage the traffic explosion. And that means as well what type of small cell are going to deploy. Is it a home eNode B, a user provisioned type of device built into, could it be set-top boxes, built into DSL modems, or being it something else? Or would it be metro cell type of deployments, which is more commissioned and deployed similar to traditional macro cells, but on the other hand, they are much more based upon the type of fiber to the antenna type of solutions. So when the operator have really made up their strategy, so decided on strategy, decided on going forward with execution, obviously spending the investment to go there, that's really the next step in the evolution. And a lot of operators is getting very close to making that big fundamental decision to go for this and go for very large scale deployment. That means that there's a number of small cell vendors, which is basically pitching in a set of unique technologies. Could be the predictive caching, it could be other type of offloading, which they are trying to use to change the game and tilt the light in their favor, etc. And that's really where a number of operators are waiting to see what innovation is going to be around the corner. Is there going to be any real next step of innovation? So there are these two camps of operators, the ones which is waiting for the next level of innovation, and at that point it's going to go ahead, and then the ones which is now more or less decided on strategy and is really just going to roll out. So
yeah.
Jason, I don't know if you want to add anything to that.
Yeah, exactly, Per. And I think it's even at a higher level, more on the business side. I mean, the reason that femtocells, did not explode onto the market as everybody had expected was the business case, right? Are we offering these? Are operators offering these femtocells for free? Do we have to buy them? And a large percentage certainly went with regards to you need to purchase these, and the price for those femtocells was obviously not in line with expectations. So certainly initially the business side of that drove the slow rate of adoption on femtocells. But like Per mentioned, the use case for the operators to offload some of that cost that's in the core of the network is helping to operators to start think of this a little different, rather than how do we fund this. It's really how do we save costs in both our RAN as well as our core by implementing femtocells and small cells in general.
Okay. Well, last question again from the audience is deals with what type of research is available around using WAN applications in acceleration-type testing devices.
Yeah, that's a good question. I'll take that, Jeff. So certainly, I mentioned about adding intelligence into the small cell. So WAN application acceleration, I think of this back in the core of the network. That's more around, application delivery. At the small cell site, that's where the actual applications are run from the small cell. That cache and intelligence can now run that Facebook application and only use the backhaul when needed. That research is going on, and that development, not just research, but actual development and features are starting to roll out into the market. There's a bunch of vendors out there today, and Intel's trying to certainly play a part in that and spread that that knowledge. But I would encourage folks to go look at that paper. But certainly, it's being active today. WAN application acceleration, that sort of thing, or application delivery, being in the small cell itself. That's underway. But I think look for more innovations to come.
Okay. Well, thank you very much. Our hour is up. Thank you so much, Byrne and Jason, for joining us today. This presentation will be made available on demand from RCR Wireless News on our website. The attendees and people who registered will get results of that. The JDSU team will get copies of all the other questions that were asked during the webinar and make their best efforts to respond to everybody. Again, thank you very much, JDSU, for joining us today, and thank you, audience, for participating.